initial point O and final point P, that is final and initial O. So distance between O and P, what is the distance between O and P? This will be 20 meter. Understood or any doubt? Understood or any doubt?
No doubt, sir.
नेक्स्ट, आगे चले भाई. Next point is about speed. First of all, let's discuss some property of distance and displacement. Remember that distance of a journey is always greater than equals to magnitude of the displacement. Since displacement is a vector quantity, it may have any direction, which means it may be positive, it may be zero, or it may be negative. That's why we are taking magnitude of the displacement or mode of the displacement. And distance can never be negative, it will always be positive or zero. So distance is always greater than equals to displacement, which also implies that if you will take the ratio, this will be distance divided by mode of displacement, which will be greater than equals to 1. So is it possible that distance will be equals to displacement? Distance is equals to exactly same as displacement. When will be it possible? Distance is equals to displacement. This is possible if and only if object move in only one direction on a straight line. On a straight line, we have two directions, forward direction, backward direction. If you want to have distance equals to displacement, object will move only in one direction. That is, either it will go forward or it will go backward. So distance may be equals to displacement in a special case, and the special case is when object move in only one direction. Second point is about distance. It can be zero, it can be positive, but it cannot be negative. On the other hand, displacement, it can be zero, can be positive, can be negative also. Understood? Now next point, we can define speed. What is speed? Speed is given by total distance traveled in 1 second or 1 unit time. Total distance traveled in 1 unit time or total distance traveled in unit time. In that case, speed can be given as distance divided by time factor. This is speed. What will be SI unit of speed? Yes, SI unit of speed will be distance in meter and time in second in SI system. This will be meter per second. What will be its dimensional formula? For distance, what is the dimensional formula for distance? L. And what is the dimensional formula for displacement? It is again L. So in case of speed, this will be L by T, that is LT minus 1. And another important point is speed is scalar quantity, because distance is scalar, time is also scalar, so speed will be scalar quantity. Next we have types of speed. Speed may be number one, यूनिफॉर्म स्पीड, ये काम घर कर लिया करो या इधर ही आके तुम्हारा बहनों का प्यार या दोस्ती जागती है। महाराष्ट्र में हूं मैं इसलिए चुप हूं, मेरे उधर होते ना तो ऐसा जवाब आता, पढ़ रहे बड़े ना तो दफा हो। हर रोज तुम्हें एक ही बात बोलनी पड़ेगी अब मुझे बार बार। देखो ये लगी हुई है। इधर लेक्चर चालू है, ऐसे बोल बोल के बता रहे दीवार को देखो मैं पढ़ रहा हूँ। हाँ जी। यूनिफॉर्म स्पीड इज, uniform speed can be defined as if an object travel equal distance in equal time interval. What will be non-uniform speed? Non-uniform speed will be in case of unequal distance, unequal distance in equal time interval. Average speed. What is average speed? Average speed is total distance divided by total time. And fourth one is instantaneous speed, which will be defined from average speed. So average speed V bar is given by total distance traveled divided by total time taken. And if you want to have instantaneous speed, this will be limit delta t tending to zero average speed. And in that case, we have instantaneous speed v is equals to dx by dt. SI unit will be same for all type of speed and their behavior will also be same, scalar. Find the speed, or let me write it as, find the average speed of a car which covers 20 kilometer at a speed of 10 kilometer per hour and 30 kilometer at a speed of 20 kilometer per hour. What will be the average speed? Average speed is given by total distance divided by total time. Total distance is 20 kilometer and 30 kilometers. So total distance is 20 plus 30 divided by total time. What will be total time taken by the car in this journey? Time is, since the speed is distance by time. So time will be distance by speed. So there will be some time taken to cover 20 kilometers and some time will be for 30 kilometer. So time taken to cover 20 kilometer will be 20 by 10 distance by speed plus 30 divided by 20 again distance by speed. So this will be V bar. 20 plus 30 will be 50 by, this will be how much? 2 plus 1.5, right? So V bar will be 50 divided by 3.5, which will be 100 by 7. What will be the unit for average speed? Yes, it is given in kilometer. So this will be in kilometer per hour. Understood? Remember, if you have kilometer per hour and you want to convert it into meter per second, then you have to multiply by a factor which is 5 by 18. And if you have meter per second and you want to convert it into kilometer per hour, you have to multiply by 18 by 5 factor. So 5 by 18 is converging factor. Understood? Understood. Next point is velocity. Yes. How will you define velocity? Velocity can be defined as total displacement in unit time. So velocity is given by velocity equals to total displacement divided by total time. What will be SI unit for velocity? Yes, SI unit for velocity, meter per second. Dimension, for displacement we have L, for time we have T. So this will be LT minus 1. And is it scalar or vector? Since displacement is vector, so velocity will also be a vector quantity. Understood? Next we have types of velocity, same as types of speed. First one is uniform speed. What is uniform speed? Sorry, velocity na? Uniform velocity. If an object covers equal displacement in equal time interval, then this is called uniform velocity. Non-uniform velocity. Yes, non-uniform velocity will be in case of unequal displacement in equal time interval. Then we have average velocity. Average velocity. Average velocity is given by V bar, which is change in position upon time interval or overall displacement upon overall time taken to cover this displacement. Then we have instantaneous velocity. Average velocity can be defined as total displacement divided by total time taken. And in case of instantaneous velocity, this is defined as limit time taken tending to zero average velocity. So this will be instantaneous velocity v equals to limit delta t tending to zero v bar, that is limit delta t tending to zero delta x by delta t, which will be dx by dt. Understood or any doubt? Yes.
Understood, sir.
Next point is about speed and velocity. Since we know that distance is always greater than or equals to displacement, and if you will divide it by time factor, distance divided by time is always positive, so it will not change inequality. This will be greater than equals to displacement divided by time, which implies that average speed of an object is always greater than equals to average velocity. Average speed divided by average velocity magnitude wise will always be greater than equals to 1. And in a special case, we can say that average speed will be exactly same as average velocity. So in which case this is possible that average speed is equals to average velocity. In which case it will be possible? Yes, average speed will be equals to average velocity if distance is equals to displacement. That is possible if and only if object is moving in only one direction on a straight path. On a straight path. Understood or any doubt? Yes. Let's say we have a particle whose position vector is given as a particle is moving with the position as x of t is equals to 2t square plus 2. Find its velocity or instantaneous velocity. Find its instantaneous velocity at t equals to 1 second. So in this case, position as a function of time t is given to us, that is 2t square plus 2, and we have to find out instantaneous velocity. Instantaneous velocity is given by dx by dt. So this will be d by dt of 2t square plus 2. So instantaneous velocity will be d by dt of 2t square will be what? Derivative of 2t square 4t plus derivative of 2 0. So velocity as a function of time t is 4t. And we have to find out velocity at time instant t equals to 1 second. So this will be 4 into 1, that is 4 meter per second. Understood? Understood or any doubt?
Understood, sir.
Another question is if an object covers half of the distance with velocity v1 and half of the distance with v2, then find average speed of the object. So how will you solve it? An object is moving to cover a certain distance, and according to question, half of the distance is covered with speed v1 and another half is covered with speed v2. We have to find out average speed. Let's say this total distance is 2x. So half will be x, half will be x. Now you can apply average speed formula. Average speed is total distance divided by total time taken. What is total distance covered in this journey? 2x. Yes or no? And what will be time? Again, time is distance by speed. So time t will be distance x divided by speed v1 plus next distance x divided by speed v2. If you will rearrange it, average speed will be 2 upon 1 upon v1 plus 1 upon v2 because x factor will cancel out. And on simplification, this will be 2 into v1 v2 upon v1 plus v2. Understood or any doubt? Yes? Okay, next point is about acceleration. What is acceleration? Acceleration is defined as change in velocity per unit time. Change in velocity per unit time. SI unit will be, let me write it as acceleration A is equals to change in velocity delta V upon time interval delta T. Delta V is V final minus V initial upon time interval T final minus T initial. So this is defined as acceleration. Now, what will be SI unit of acceleration? SI unit of acceleration will be SI unit of velocity, that is meter per second, upon SI unit of time, that is second.
Square.
So this will be meter per second square. Yes. What will be its dimension? Because acceleration is change in velocity upon time, so its dimension will be dimension of velocity upon dimension of time. Dimension of velocity is lt minus 1. Dimension of time is t. So dimension of acceleration will be lt minus 2. What will be its nature? Is it scalar or vector? Acceleration is a vector quantity. Understood or any doubt? Yes. Now we have types of acceleration. In which first one we have uniform acceleration. Second one is non-uniform acceleration. Average acceleration. And instantaneous acceleration. So in this case, how will you define uniform acceleration? Yes. Yes. How will you define uniform acceleration? Uniform, because acceleration is change in velocity. So uniform acceleration can be defined as equal change in velocity in equal time interval. Non-uniform will be unequal change in velocity in equal time interval. What will be average acceleration? A bar and instantaneous acceleration A. So we define average acceleration equals to A bar as overall change in velocity, that is V final minus V initial upon T final minus T initial. Sometimes we write it as A bar is equals to delta V by delta T. This is average acceleration. And instantaneous acceleration can be given by A, which will be limit delta T tending to 0 A bar. So acceleration A will be limit delta T tending to 0 delta V by delta T, in which case we have acceleration A as dV by dt. Since V is dV by dt can be written as d by dt of V, d by dt of V, and V is nothing but dx by dt. So acceleration can also be defined as d square x by dt square, which means second order derivative of position x is acceleration, and first order derivative of position x with respect to time is velocity. Understood or any doubt? Yes. Okay, next point is different cases of acceleration. Case first, acceleration is delta V by delta T. If I said that there is no acceleration in the system is 0, it means delta V by delta T will be 0, which means delta V will be 0. delta V is nothing but V final minus V initial will be 0. And finally, V final will be equals to V, which means if there is no acceleration in the system, there will be no change in velocity. Or in other words, if you want to change the velocity of a system, you have to apply some external force. Because if there will be some external force, there will be some acceleration, and that acceleration will change the velocity. It can also be stated as no object can change its velocity by itself. There has to be some external agency which will change its velocity. Understood or any doubt? Second point is effect of acceleration on the velocity, and it can have two types of effect. First one is if the object is moving in this direction with velocity, let's say v, and there is an acceleration which is working into the same direction with magnitude a. In that case, this acceleration is taken as positive and it will increase the speed or the velocity of the object. This is known as accelerated motion. Third case is an object is moving in a particular direction with certain velocity v, and an acceleration is working on this system in opposite direction, that of velocity v. This is acceleration a. In this case, acceleration a is taken as negative and it will decrease the speed or velocity. Understood or any doubt? Yes?
Understood, sir.
Okay. What was the last topic in chemistry? Yes?
Sir, chemical bonding.
Sir, your
Sir,
voice
you
is
are
not
mute.
audible.
Yes, sir.
Sir, you are on mute.
Any doubt?
Sir, you are on mute. We didn't hear anything.
Okay. There are two types of overlapping, sigma overlapping and pi overlapping. Sigma overlapping is a type of overlapping in which orbitals of the atom will overlap on a single axis. And this axis is known as internuclear axis. In this type of overlapping, sigma bond is formed. Area of extent in this overlapping is way greater than the another overlapping which happens in pi bond. So strength of sigma bond is greater due to area of extent. Sigma bond or sigma overlapping can be in the following three ways. Either it will be SS type or SP type or PP type. SS type of sigma overlapping is found in H2. SP type overlapping is found in HX family complete. And PP type overlapping can be found in X2 halogens, that is F2Cl2, Br2 and I2. And apart from that, we have oxygen and nitrogen also. There are other examples also. CO2 is also an example where PP sigma overlapping will take place. Second overlapping we have pi overlapping, or this is also known as partial overlapping. In this overlapping we have two different parallel axes and there are orbitals on these parallel axes which orbitals overlap with each other. So this type of overlapping is also known as parallel overlapping. Parallel overlapping. In this overlapping, extent of area is very less. Extent area is very less, due to which bond will be weak. And in this type of overlapping, pi bond is formed. So if we are looking for strength, in that case, sigma bond will always be stronger than pi bond. And the reason for it, area of overlapping in sigma is greater than area of overlapping in pi. Another important point is, if there is only one bond in any molecule, then it will always be sigma. If there are two bonds, then one bond will be sigma and another one will be pi. If there are three bonds, one bond will be sigma and remaining two will be pi. Understood? Understood or any doubt?
No doubt, sir.
Question is find the number of sigma bonds and pi bonds in the following. Let's say first one is CO2. CO2 is C double bond O double bond O. How many sigma bonds are there and how many pi bonds are there? Remember, the first bond is always sigma and remaining other bonds will be pi. So in CO2, how many bonds are sigma? Yes, sigma bonds will be 2, pi bonds will be, that is also 2. First bond is sigma, remaining bond is pi. If I have ammonia NH3, its bonding is N bond H, bond H, bond H with lone pair. How many sigma bonds are there? 3. How many pi bonds are there? 0. And how many lone pairs are there? Electrons which are not in bond are known as lone pairs. So there are 1 lone pair in ammonia. Understood? Next point is C2H4. C2H4 is C double bond C, bond H, bond H, bond H, bond H. In this case, what will be number of sigma bonds? So one bond is sigma, sigma, sigma and sigma. In 2 bonds, one will be sigma, another one will be pi. So there will be total how many? 1, 2, 3, 4 and 5 sigma bonds. And pi bonds will be how many? 1 pi bond. Understood? Fourth is C2H2, which is given by C triple bond C bond H bond H. This will be sigma, this will be sigma. In C triple bond C, 1 bond will be sigma, remaining 2 will be pi. So how many sigma bonds are there in C2H2? There are total 3 sigma bonds and pi bonds will be 2. Understood or any doubt? Yes? Understood or any doubt? Okay. Another segment of VBT is hybridization. To know the hybridization of any atom, you have to find out number of sigma bonds and number of lone pairs. आईलेट से सोल्व करना पड़ेगा 1 लेट करके 1 प्लस ln x जैसा कुछ आता है याद गूगल कर लेना मिल जाएगा नेक्स्ट कॉन्सेप्ट इज hybridization. First point, hybridization is a hypothetical concept. Hypothetical concept which is used to explain the structures of the molecule. And to calculate hybridization, second point, hybridization work for an atom. We cannot find out the hybridization of a molecule. Hybridization has to be found for a single atom. This atom may be any atom, but in general, in most of the cases, central atom is the target. We will find out hybridization for central atom. Third point, to know the hybridization of any central atom, you have to find out steric number. Steric number. How do we find out steric number? Steric number given by Sn is equals to sigma bonds plus number of lone pairs. And there are different possibilities. Steric number, hybridization, and then geometry of the molecule. So if steric number is 2, hybridization will be sp, and in that case geometry is linear. Angle will be 180 degree. So if we have, let's say, B atom, A bond, this angle will be 180 degree. Next is steric number 3, hybridization will be sp2, and geometry will be trigonal planar. Trigonal planar. B will be at center, and there will be 3 bonds making a triangle. Angle will be 120 degree. Next we have steric number 4. In that case, hybridization is sp3, and geometry will be tetrahedral, which will be something like this. B atom, one of the atom will be here, one here, and one will be in backward direction. And in tetrahedral, this angle is given by 109.4 degree. Next we have number 5. In case of number 5, hybridization will be sp3d. What will be geometry in sp3d? Yes, anyone? Yes, geometry in case of sp3d will be trigonal bipyramidal. It will be something like this. There will be central atom B, 3 bonds will be in a plane, and remaining 2 bonds will be upward and downward of the plane. Then we have steric number 6. For that, hybridization will be sp3d2. What will be the geometry in this case? sp3d2. Yes, octahedral. And rough sketch for octahedral will be like this. There will be a square planar type arrangement, and central atom will be at this point, and there will be bond like this. Remaining 2 bonds will be one upward and one downward. Understood? Understood? Yes, or any doubt? Any doubt?
No, sir.
No, sir.
Okay, now we can do some questions to find out hybridization. Let's discuss CO2. What will be the hybridization of CO2? CO2 is C double bond O double bond O. And if you look at the hybridization of carbon, in this case, carbon has 2 sigma bonds, and in case of carbon, there are 0 lone pairs. So steric number will be sigma bond plus lone pair, that is 2 plus 0 will be 2. Since steric number is 2, its hybridization will be sp, and due to which its geometry will be linear. That's why structure of CO2 is given as C double bond O at 180 degree angle. One more example we can have CH4. CH4 can be given like this: C bond H bond H bond H. So how many sigma bonds are there? In CH4, how many sigma bonds are?
4.
4 sigma bonds. How many lone pairs are there? 0. So
0.
steric number will be sigma bond plus lone pair, that is 4 plus 0 will be 4. If steric number is 4, what will be hybridization? It will be tetrahedral.
sp3.
Tetrahedral. And hybridization will be sp3, right? Geometry is tetrahedral. Hybridization is sp3. So if you will represent it correctly, it will be like this: carbon, bond H, bond H, bond H, and bond H. And this angle will be 109.5. Understood or any doubt? Yes. Let's say we have ammonia. Ammonia is given by this: N bond H, and one lone pair. If you will find out sigma bond in this case 3, lone pair in this case 1, so steric number will be sigma plus lone pair, that is 4. And in case of 4, hybridization is sp3. What must be geometry for sp3? For sp3, geometry will be tetrahedral. But in ammonia, there is one lone pair. This lone pair will change the geometry of ammonia from tetrahedral to pyramidal. So the geometry of ammonia is given by pyramidal, triangular pyramidal. In fact, the structure will be in reality like this: N bond H bond H bond H, and there will be one lone pair here. Understood or any doubt? Yes. Any doubt?
No,
No, sir.
sir.
No doubt. Now next point is about electronic configuration of a molecule. As we have a concept for electronic configuration of atoms, Afbauer rule, same we have for molecule. So this will be electronic configuration for electronic configuration for molecule. This concept is taken from MOT, that is molecular orbital theory. There are two different series to write the electronic configuration of a molecule. First one is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then we have sigma 2pz. Then we have pi 2px equals to pi 2py. And then pi star 2px equals to pi star 2py. And finally we have sigma star 2pz. This series will work for oxygen O2 and fluorine F2, neon Ne2, and for all the molecules which have electrons greater than 14. Next series is, there will be next series. In that series, this particular atomic molecular orbital will go somewhere here. And the series will be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then we will have pi 2px equals to pi 2py. And then we will have sigma 2pz. After that, we will have pi star 2px equals to pi star 2py. And then we have finally sigma star 2pz. This series will work for the molecules other than oxygen and fluorine. Understood? In this concept, we have two types of orbitals. One orbital is with star and one orbital is without star. For example, we have sigma and sigma star. We have pi and pi star. Orbitals with sigma and pi, that is orbitals without star. Orbitals without star are known as bonding molecular orbitals. Bonding molecular orbitals. And orbitals with star are known as antibonding molecular orbitals. Second point is, using this electronic configuration, we can find out bond order, which is EO, which will be equals to NB minus NA divided by. In this case, NB is number of bonding electrons and Na is number of anti-bonding electrons. Remember, if Nb is greater than Na, in that case, molecule exists. And if Nb is equals to Na or Nb is less than Na, in that case, molecule does not exist. Molecule does not exist. Understood? Question will be like, find bond order in helium molecule He2, or can helium exist in dimer form? Can helium form He2? So in this case, we have two helium atoms. And for two helium atoms, total number of electrons will be two atoms. Number of electrons for helium atom is 2. There will be 4 electrons. So you can fill these 4 electrons in this series. So this will be electronic configuration of helium. Electronic configuration for helium can be given as sigma 1s2 sigma star 1s2. So 4 electrons are distributed in s orbitals, sigma 1s and sigma star 1s. In this case, if you will look for number of bonding electrons, it is 2. Number of anti-bonding electrons, it is also 2. If you will find out bond order, this will be number of bonding electron minus number of anti-bonding electron divided by 2. So we will write it as 2 minus 2 by 2. Bond order will be 0. Zero bond order indicates that helium He cannot form He2 molecule. Understood? Understood or any doubt? Yes?
No doubt, sir.
Okay, next point in the same concept may be about nature of the molecule. In this category, we take two possibilities for a molecule to be either diamagnetic or paramagnetic. Any chemical substance will be diamagnetic if it has no unpaired electrons. No unpaired electrons. All the electrons are paired. All electrons are paired. In that case, the substance will be diamagnetic. In case of paramagnetic, at least one electron is unpaired. At least one electron is unpaired. For example, in case of helium, we have total 4 electrons, and all the 4 electrons are given as sigma 1s2 and sigma star 1s2. So these 2 electrons are paired up and these 2 electrons are paired up. No electrons are unpaired, which means helium He2, if it exists, will be diamagnetic in nature. Understood or any doubt?
No doubt, sir.
Okay. Next point we have H bonding, that is hydrogen bonding. Remember, hydrogen bonding will be there if and only if hydrogen atom is connected with phone. Phone stands for fluorine, oxygen and nitrogen. If there is an atom, hydrogen atom H, which is connected with either F or O or N, then this hydrogen can form a weak type of bond with another atoms which are again phone, but in another order. This will be NON. In this case, the bond formed by hydrogen is known as hydrogen bonding or H bond. So H bond is a special type of bond which will be formed if and only if hydrogen atom is bonded with fluorine, oxygen or nitrogen, and the same hydrogen will try to interact with nitrogen, oxygen or fluorine. That interaction is known as H bond. Reason for H bond is electronegativity difference. If someone asks you what is the reason for H bonding, reason for H bonding is electronegativity difference. Electronegativity Electronegativity difference between chlorine, oxygen, nitrogen, and hydrogen. Understood? Understood or any doubt? Any doubt? Okay. Bond parameters. Bond parameters are bond length, bond angle, and finally bond enthalpy. Remaining will be done in next session. What was the last topic in maths? Yes,
Reciprocal function.
reciprocal function. Next function is square root function. दिखा ना?
ये मल्टीप्लाई में असं ये मल्टीप्लाई पावर में नहीं मल्टीप्लाई
Square root function is a function which is given by y equals to f of x equals to root x. Its graph is like this. So from graph it is clear that this function can take only positive values of x. Which means its domain will be positive real numbers only, including 0 also. 0 can also be there. So x will be greater than equals to 0. And if you will look for the range, it starts from 0 and it will go to infinity as you will increase the input. So its range will be again r plus including 0, which can also be given as 0 to infinity, like this is known as square root function. Square root function is very important. There will be lots of questions on this concept. Remember, in square root, you cannot have negative input. This graph states that in square root, you can have only positive input. So if I have something like square root of f of x and I want to know its domain, so its domain can be calculated by the condition f of x has to be greater than equals to 0. For example, if I have a square root of x plus 5, what will be its domain? So its domain, according to definition, x plus 5 expression has to be greater than equals to 0. So x has to be greater than equals to minus 5, which means its domain will be from minus 5 to infinity, including minus 5. Are you getting it? ये ब्रैकेट के साथ ये है क्या?
मल्टीप्लाई में और इसकी ये आर्गुमेंट है इसके आर्गुमेंट
मतलब ये इसकी पावर में ऐसा बोल
नहीं नहीं मल्टीप्लाई में
मतलब दिस मल्टीप्लाई और क्या करना?
आंसर निकालना
आंसर निकालना. कैसा आंसर आ रहा? फाइनाइट वैल्यू आ रही, क्या आ रही?
फाइनाइट वैल्यू
क्या क्या ऑप्शन है?
4 2 6 में वर्क मतलब एक फाइनल आंसर ही नहीं आ रहा है.
ओके. फाइंड द डोमेन ऑफ स्क्वायर रूट. Find the domain of square root x square plus 1. Yes, what will be its domain? Because for domain, input value has to be greater than equals to 0, which means x square plus 1 has to be greater than equals to 0. And if you will look at the expression x square plus 1, it will always be greater than equals to 0, because due to power 2, the output will also be positive. Or you can also state it as, if you will look at the graph of x square plus 1, the graph will start from here. So from graph, it is clear that x square plus 1 is positive for all possible input values of x, which implies that domain of this particular function will be all real values. You can put any real value in this function, it will be well defined. Understood or any doubt? Yes. Remember, there is a note point. If we have square root of x square, this will be taken as mod x. Next is modulus function. Modulus function, which is also known as absolute value. This is defined as y is equals to f of x is equals to mod x, which is x for x greater than equals to 0 and minus x for x less than equals to 0. If you will plot the graph of mod x, this will go like this. This is the graph for y equals to mod x. From graph, it is clear that its domain will be all possible values of x. That is, it can take any real value, and its range will be 0 to infinity, which means it will give only positive outputs. Either it will give 0 or positive outputs only. So range will be 0 to infinity, that is close bracket 0, open infinity. Understood? Next function we have signum function, which is defined as y is equals to f of x is equals to signum x, which is given by mod x by x if x is not 0 and 0 if x is 0. If you will solve it further, if x is not 0, in that case x either will be positive or will be negative. So there will be -1 for x less than 0, there will be 0 for x equals to 0, and there will be +1 for x greater than 0. If you will plot the graph, it will be like this. 0 will be for 0, and for greater than 0, any value greater than 0 will have 1. So this point is 1. And for any value less than 0, will give -1. So this point is -1. From the graph, domain will be all real values of x. It can take any real value. What will be its range? From the graph, if you will look at the graph, it can either take -1 or 0 or +1. It will not take any other value, or it will not take any value between 0 and 1 and 0 and -1. So it will take discrete values that will be either -1 or 0 or +1. So its range will be -1, 0 or +1. Then we have greatest integer function. Greatest integer function, which is also known as step function or floor function. Its definition is y is equal to f of x is equals to greatest integer x, which represents greatest integer which is less than or equal to x, which means if I have, let's say, greatest integer 1.5, so this will be like this. If I plot 1.5, this will be somewhere here, and take all the integers which are less than 1.5. So integers less than 1.5 will be 1, 0, -1, -2, and so on. Out of these integers, I have to select the greatest one. So out of these integers, greatest will be 1. So the value of greatest integer 1.5 will be 1. In other words, we can write it as for different branch of x, we have different value for greatest integer x. For example, if x is in between 0 to 1 including 0, greatest integer will be 0. If x is in between 1 to 2, greatest integer will be 1. If x is in between 2 to 3, greatest integer will be 2, and the story goes on. If x is in between -1 to 0, greatest integer will be -1. If x is in between -2 to -1, greatest integer will be -2, and the story goes on. If you will plot the graph, that will be far more easy to study the properties of greatest integer. This is greatest integer x and y. For 0 to 1, output is 0. So this will be 0 to 1. For 1 to 2, output will be 1. So this point will be 1. This will be 2. For 2 to 3, output will be 2. This point will be 2. And the graph will go on like this. In negative direction, open will be here, close will be here. This is -1. This will be open, this will be closed, -2, and so on. Understood? If you will look at its domain, it can take any real value R. Input may be anything. But if you will look at the range, greatest integer function, according to its definition, will give only integers as answer. It cannot give decimal point or it cannot give fractional number output. So its range will be its output, which is integers only. Maybe positive integer, maybe negative integers, but range will be integers only. Understood or any doubt? Understood or any doubt?
No doubt, sir.
Next is fractional part function. Fractional part function is given by y is equals to f of x is equals to fractional part x, which is defined as x minus greatest integer x. Graph for fractional part is like this, x-axis and y-axis. The concept of fractional part function is that any number in nature has integral part plus fractional part. Fractional part. Let's say number is x. Then its integral part is calculated by greatest integer x. And its fractional part is calculated by fractional part x. So if you will find out fractional part x, This will be x minus greatest integer x. And the property of fractional part function is that if you will give it some input, let's say 0.1, it will give answer in fractional values. So fractional part of 0.1 is itself 0.1. If I write 1.2, in that case fractional part will be 0.2 because in 1.2 1 is integral value and 0.2 is the fractional part. If we have 3, there is no fractional part, so answer will be 0. If we have -4, again no fractional part, answer will be 0. But if I have minus 3.6, in that case, its fractional part will be 0.4. If you will plot the graph, you will understand that the graph starts from 0 and it will go till 1. Fractional part cannot attain 1 because 1 is integral part. And the property of fractional part is that it will give only fractional part. So graph will be like this. This will be the graph, which states that fractional part will always be positive and 0 to 1. So if you are looking for its domain, will be all possible real values, and if you are looking for its range, it will be in between 0 to 1 always. It cannot attain 1, but it can attain 0. So range will be 0 to 1 including 0. Understood? Next is exponential function. If we take y is equals to f of x is equals to e raised to power x, its graph goes like this. So its domain will be all real values and its range will be all real values and range will be only positive values and it cannot attain 0. So this will be 0 to infinity, which is same as r plus. If we have a raised to power x and let's say a is greater than 1, in that case graph will go like this. This will be the graph. This point will be 0, 1. Same is true here. This will also be 0, 1. If you will look at the domain from the graph, it can take any possible value. And if you will look at the range, again it cannot be negative. So it will be 0 to infinity. Only positive real numbers. If we have y equals to f of x equals to a raised to power x such that a is in between 0 to 1, then the graph will go like this. This point will be again 0, 1. Graph will be, from graph domain will be R. Range is still 0 to infinity. That is R plus. Next one is Next one is log function. In that case, we have y equals to f of x equals to log base ax, and there are two possible cases. Either a is greater than 1 or a is 0 to 1. If a is greater than 1, the graph will be different, and for 0 to 1, graph will be different. In this case, graph goes like this. Domain, from the graph, it is clear that it can take only positive values. So domain will be r plus, this is open. In logarithm, we cannot input 0 also. So we can input only positive values. In case of 0 to 1, graph will go like this. Again, domain will be r plus only, but there is no criteria for range. From graph, it is clear that it starts from minus infinity to plus infinity. So range will be all possible real values are. Same is true in this case. Minus infinity to infinity, that is r. If you will take a special function y equals to f of x equals to log base ex, which is also given as ln x. Since value of e is greater than 1, so graph for ln x will be like this. This is ln x. And in this case, again, domain is only positive real values, but there is no criteria in range. It will be from minus infinity to plus infinity open interval. If you are interested in this point will be 1, 0 in all the graphs. 1, 0. Again, 1, 0. Understood? Understood or any doubt? Yes, any doubt?
No, sir.
Hello,
Next
sir.
point. In next point, we will try to find out range and domain. But before
Sir.
that, let me give you a simple concept, that is operations on real functions. In this case, let's say we have two functions f defined from set A to set B. So let's say I will write it as defined from domain 1 to R and G from D to R. And we want to add these functions, subtract and multiply. Remember that all the operations on these functions will be valid on the common domain of both functions f and g. So we can write it as operations on f and g are defined only on common domain. Common domain of function f and g. And common domain will be D1 intersection D2. If D1 is domain of function f and D2 is domain of function g. Now, if you are given with f plus g of x, it will be f of x plus g of x. You are given with f minus g of x, its meaning is f of x minus g of x. If you are given with f into g of x, it implies that it will be same as f of x into g of x. Similarly, f by g of x is nothing but f of x divided by g of x. provided g of x is not equals to 0. Let's say we have a function f of x is equals to x square, and we have a function g of x is equals to 2x. Now, first of all, find the domain of f. Domain of function f will be R. Domain of function g is also R. So if you will take domain of function f intersection with domain of function g, it will be complete R, which means these two functions can be added, subtracted, multiplied, and divided. So if you will find out f plus g of x, this will be f of x plus g of x, which means x square plus 2x. You are going to find out f minus g of x. It can be written as f of x minus g of x, which will be x square minus 2x. If you have f into g of x, this can be given as f of x into g of x, which will be x square into 2x, that is 2x cube. If you are going to find out f by g of x, this will be f of x divided by g of x, which means this will be x square by 2x, x factor will cancel out. We will have x by 2. These are the operations which can be operated on two functions, provided their domains have some elements in common, because these operations will be defined only on the common elements. Understood? Last topic is composition of two functions. In this concept, one of the function will behave as input for another function. So to define composition of two functions, first of all, we have to be careful about their domain. So let's say I have a function f, which is defined on set A to B, and there is another function g, which is defined on set B to set C. So function f and g are defined in such a way that output of function f will work as input of function g, which means range of function f is the domain of function g. If this is the case, we can define composition of two functions. How will it work? It will work in this way. Let's say this is set A, this is set B, and this is set C. Set A to set B, we have a function which is given by f. And set B to set C, we have another function which is given as g. If I take an element x from set A and I input it into function f, I will get some output which will be f of x. Now the element of set B are input for g, which means f of x will behave as an input for g, and in C we will have g with input f of x. So this arrangement is known as composition. It indicates that if you will take input x from set A, you will get output in set C by using a special function which is g of f. G of f is g as a main function and f of x as its input. Similarly, we can define f of g, but in this case, f of g is not valid because output of g is c and input for f is a. So we cannot guarantee that range of g is domain of f. But if I define it as that range of function g is a subset of domain of function f. In that case, I can also define f of g of x, which will be f of g of x. Let's take an example to understand it. Let's say I have a function f of x, which is x square. I have another function g of x, which is, let's say, mod x. So first of all, let's look at the domain and range of f. What will be domain of f? Any real number. And what will be its range? Its range will be only positive real number, including 0. So I will write it at 0 to infinity. Another function g is mod x, which can take any real value r, and it will give output as 0 to infinity. Now the question is, should I compose f and g? Since range of f is a subset of domain of g, range of f is a subset of domain of g, which implies that composition is possible. So I can define g of f of x, which will be nothing but g of f of x, which means in function g, you can input f. So function g will have input x. Sorry, input f of x. What is f of x? F of x is x square. So x square will be working as input for g. What is g? G is mod. So this will be mod with input x square. If you are going to define 4, that is also possible. So f of g of x will be f as main function with g of x its input. So this will be f. G of x is mod x. F is x square. Mod x will be input. So we can write it as mod x to the whole square. Are you getting it? Yes or no? Yes or no?
Yes, sir.
Okay. Next point is inverse of a function. Remember that only that function will be invertible or will have inverse, which function is bijective. Invertible functions are bijective, or vice versa. Bijective functions are invertible, which implies that only those functions will have inverse which are 1 as well as 1 2. So bijective means two-jective. Two-jective means one is injective, another one is surjective, which means function has to be 1 as well as on 2. If we have a function which is 1 as well as on 2, this function is known as invertible and its inverse exists, and we can find out its inverse. If we have a function which is 1 but not on 2, it's in 2, then we cannot find out its inverse, and its inverse does not exist. So the question will be, check whether the given function is invertible or not. So you have to check for its behavior as 1 and on 2. For example, let's say I have a simple function, very simple function f of x, x. Its domain is R. Its range is also R. And if you will plot the graph of y equals to f of x, this will be like this. From graph, it is clear that it is 1 and its range is same as its codomain. Codomain is also R, range is also R. So this is on to also, which means the given function f of x equals to x is an invertible function. f of x is equals to x is known as identity function, which implies that identity functions are invertible functions. Let's say I have y is equals to f of x is equals to x square and f is defined from R to R. Check whether the given function is invertible or not. So if you will go by the graph for x square is like this, and you will notice that by horizontal line test, there are two input for the same output. Sorry, there are two input for the same output. For example, if this is 1, answer will be 1. If this is -1, answer will be 1. So the behavior of this function is such that if you are taking 1 or -1, answer is always 1. So this is many one type. And if it is many one, it cannot be invertible. So it's not invertible function. Understood? इसके क्वेश्चन भाई अगले लेक्चर में करेंगे, बाकी अभी भी ये बहुत बचता है, बहुत सारा कॉन्सेप्ट है इसमें। Okay, in general aptitude we have clocks. Any clock has three ends. One is known as RM. Second one is minute hand. Third one is second hand. R hand is shorter in length. minute hand is comparatively larger in length. And then we have second hand. Now all these hands will cover the circumference of clock in different time interval. We are interested in those time intervals as well as we want to know what will be the angle between two hands when they are at any particular position in clock. So let's say first of all we have okay, how many time it will take to complete one revolution, one round of the clock? Yes. How many time will it take to revolve once? Yes, anyone? बता दो भाई. How many? How much time our end will take to complete one cycle or
Sir,
one
12 hours.
revolution? Yes,
12 hours.
12 hours. And if it will complete one revolution or one cycle, it will cover 360-degree angle. Yes or no? So in 12 hours, we have 360-degree. In 1 hour, we will have 360-degree divided by 12. That will be 30-degree. Yes or no? It means this is, let's say, 12, this is 1. If R goes from 12 to 1, that will be complete 1 hour, right? So in that case, this angle will be 30-degree. Understood? Now, if you will convert the time into minutes for the hour hand, 1 hour is 30-degree. In 1 hour, we have 60 minutes. So in 60 minutes, R and travels 30-degree. In 1 minute, it will travel 30-degree divided by 60. That is 1 by 2-degree, which is very less. That is the reason Rn seems us to move very slowly, because the angle traveled by it per minute is very small. And if you will convert it into second, it will be far more smaller. 1 minute is 1 by 2-degree, and 1 minute is 60 seconds. So in 60 seconds, it travels 1 by 2-degree. In 1 second, it will travel 1 by 120-degree. Yes, any doubt in it? Any doubt?
No,
Okay,
sir.
next is minute hand. So how much time will it take to complete one cycle? Yes. How much time? Anyone?
Sir, 480 minutes.
480 minutes to complete one cycle.
Yes, sir.
Sir, 60 seconds.
60 seconds.
So 720 minutes.
मिनट वाली स्विंग एक चक्कर लगाने में कितना टाइम लेती है, ये क्वेश्चन है.
Sir, 60 seconds.
60 सेकंड के 60 मिनट?
मिनट सर, 60 मिनट।
धन्यवाद। क्या होगा इस देश का भाई, बहुत बुरी हालत। 60 minutes, and in one cycle it will cover 360 degree. So 1 minute will cover 360 divided by 60. So 1 minute it will travel 6 degree, right? Now 1 minute is 6 degree. 1 minute is 60 seconds. 6 degree. So 1 second will be 6 by 60. That is 1 by 10 degree. So minute end in 1 second travels 1 by 60 degree. Yes. Now we have second hand. How much time it will take to complete one cycle?
Sir,
Second
this
hand,
one 60 second.
1 minute. That is 60 seconds. 1 minute. And it travels in 1 minute 360 degree. Which is why second hand is the fastest. Hello. हाँ बोलो ना. अभी बता रहे हो तुम मुझे. चलो आता. 10:20 तक होगा लेक्चर बट ये. चलो 11 बजे तक ही है क्या? आता. One revolution means 1 minute, and in 1 minute it will travel 360 degree, which means in 60 seconds it travels 360 degree. So for 1 second it will travel 6 degree. Understood or any doubt? Another important points are in 60 minutes, the minute hand gains 55 minutes on the hour hand. 55 minutes on the hour hand, which means it will travel 55 minutes more. Understood? Next one is in every hour. Minute in every hour, minute hand and hour hand coincide once. Coincide once. Next is the hands are straight line. When they are coincident or opposite to each other. Each other. Which means if this is clock and let's say this is R end and this is minute hand and they are opposite to each other. They will be in straight line. This is H, this is M, and the angle between them will be what? 180 degree. Same is the case if they are coincident to each other. So let's say this is minute hand and this is R end. In that case, angle will be 0 degree. Understood? Next point is when minute hand and R hand are at right angles, they are 15 minutes apart. They are 15 minutes apart, which means if R end and minute hand are at right angle, there will be time gap of 15 minutes. 15 minutes will give certain amount of angle and it will be approximate 90 degree. Next is when the hands are in opposite direction, they are 30 minutes apart from each other. So let's say this is 12, 1, 2, and 3. So there will be 15 minutes here, right? And this will be here. And if they are in opposite, one is here, one is here, then this is 180 degree, but angle will be, time will be 30 minutes. This is 12, this is 3, and this will be what? 9. So 9, 10, 11, 12, 1, 2, and 3. So 15 minutes will be here, and 15 minutes will be here. 30 minutes. Understood? In this case, it will be 15 minutes apart. Understood?
Yes, sir.
Next is if a word 8.15 when the correct time is 8. When the correct time is 8. So what do you think? Both is fast or slow? Correct time is 8 and it is showing 8.15. That is 8 o'clock and 15 minutes extra. It means watch is fast. If A watch show 7:45 when correct time is 8. Is it slow or fast? Correct time is 8, but watch is showing 7:45. It means watch is slow. Understood or any doubt in it? Yes. Okay, let's do some questions. Question number 1. Find the angle traveled by. Find the angle traveled by RN in 5 minutes. What will be the answer? In 1 minute, we have for RN. In 1 minute, we have 1/2 degree. So in 1 minute, it travels 1/2 degree. In 5 minutes, it will travel 1/2 into 5. That is 2.5 degree. Yes or no? Find the angle traveled by RN in 30 minutes. So what will be the answer? In 1 minute, it travels 1/2 degree. So in 30 minutes, it will travel 1/2 into 30 degree. That is 15 degree. Yes or no? Question may be like this. In how much time? In how much time RN will cover 90 degree? So we know that in 1 minute, it travels 1/2 degree. So what do you think how much time it will take to cover 90 degree? 1/2 degree will be covered in 1 minute. 1 degree will be covered in 2 minutes. And according to that, to cover 90 degree, it will take 2 into 90. That is 180 minutes. Yes or no? 180 minutes means how much time? If you will divide it by 60, this will be 3 hours. Yes or no? Let's say we have to find out the angle traveled by minute hand in 30 seconds. Question number 2. Find the angle traveled by second hand in 15 minutes. Question number third. How much time does RN take to cover 30 degrees? Question number 4. How much time does minute hand take to cover 30 degrees? Any doubt? Let's say we have one more question. Find the angle between R hand and minute hand of a clock when the time is 3:25. To find such type of questions, you have to find out angle traveled by R end and angle traveled by minute end. So if it is 3 complete, then there will be, if it is 3 complete, then there will be, minute end will be somewhere here. And it will travel the angle in next 25 minutes. 4 minute hand, 4 minute hand, how much degree it will travel in 1 minute? 4 minute hand. Minute hand in 1 minute. This is minute hand. In 1 minute, it travels 60 degrees. In 1 minute, it travels 60 degrees. In 25 minutes, it will travel 25 into 6. That is how much? 150 degrees.
150.
Now, for R1. For Rn, we have total how much time? 3 hours and 25 minutes. That is 25 by 60, which will be how much? And this will be 12. Yes or no? Yes or no? So total time we have, that is
41 by 12.
41 by 12. Our hand travels in 1 hour how much degree? In 1 hour, it travels, I think, 30 degree. So in 41 by 12 hours, it will travel into 41 by 12, which will give 102.5 degree. So angle between them will be 150 degree minus 102.5 degree, and this will be 47.5 degree. Understood? बाकी कल कराता भाई, आज थोड़ा काम है, मुझे निकलना पड़ेगा। सेव करने की। क्या डेट है भाई आज? यस 16 ना। हाँ, इधर जाना है, पेपर है इधर बच्चों का, सोना पड़ा हूँ। कुछ भी बोल रहा है तो पता नहीं क्या बोल रहा है। पीडीएफ भेज रहा हूँ भाई, ये चैट बॉक्स से डाउनलोड कर लो। चेक करें, पीडीएफ आया होगा डाउनलोड करने से। कर लिया डाउनलोड?